Okay, in this in this hour, I will continue in human cognition and light intensity and so on. The eye is an interesting adaptive measuring organ, but it is not. It's a measuring organ. It is sensitive to light, but it is not like an voltmeter. For the voltmeter, difference between 35 and 45 is 10, and difference between 120 and 130 is another 10. These are the related intensities associated with that kind of difference. But human eye is adaptive. So difference between 35 and 45 is perceived as bigger than difference between 120 and 130 because of the relative intensities. The percent difference between 35 and 45 is much bigger, like how much? Let's say 30%, like 10 is 30% of the 35. So like 28%, 25% or whatever. If it was 40, it is 25%. But from 120 to 130, it is 10 is less than 10% difference. So percent difference is more important in our cognition. Therefore, we call it more like logarithmic response. If the value is too much, if it is too bright, differences in brightness doesn't matter that much. But if it is too dark, little bit increase is more noticeable. So that is important. So difference between 10 to 11 is 10%, 50 to 55 is another 10%. So the perception becomes similar in those values. So it is not like, as I said, it is not like measuring device like voltmeter. So human eye perceives light comparatively. We try to inverse that so that our intervals become equally separated. If we directly control the voltage when we are increasing, for example, light level 0, light level 1, light level 2, 3, 4, 5, 6, 7, 8, if it is directly related to light level voltage or whatever watt electrical value, the differences won't be equal. The changes will be more significant at the beginning, but the less significant at the end. So therefore, we have to remap it, put smaller intervals at the beginning and larger intervals at the end. So for that purpose, some devices, it's true for hearing as well, some devices use this as an inverse logarithmic controls, inverse logarithmic potentiometers, inverse logarithmic control for audio devices and light devices, so that the changes are equally separated, but the value, electrical value sent to the device is very small, inversely logarithmically proportional. Then we have equal levels in illumination or screen or whatever kind of perceptual receptor. Furthermore, screens don't behave linearly, so things like gamma correction must be also taken into account, because when you send 5 volts to the LCD display and 10 volts to LCD display, the amount of light does not double. So that must be also considered. How much eye is perceived, how much screen device is behaving, and overall it must be balanced equally so that you have a smooth response. When you have different monitors on the same computer, on the same graphics card, when you swap your monitor from one when you swap your monitor on the same graphics card, usually type of the monitor must be given to the graphics card driver information so that correct amount of voltage levels are provided for correct gamma correction, because not all monitors respond similarly to the same electrical signals. Color 190 may look different on one Sony monitor, another monitor, for example, an LG monitor, may display that color differently because they have been using different material in their construction of the screen. We call it as gamma correction for R, G, and B differently. Again, this is related to visible angle. We move our eyes left and right as we read. We move our eyes, and it is also important in person-to-person contact. I am looking at you, for example, so that you can listen to me, and I don't see your faces, I don't see your avatars, but I am assuming that you are looking at me. I am talking. So in order to read, we move our eyes. We move our eyes to the words in order to understand. So our eyes are not like CCD cameras, which stay still. They should rotate because only one part, the fovea, is very good. The rest is not as good as we have seen in the past. So we have to rotate. The angle is 2 degrees. Peripheral vision, as I said, is much better around edges with the road sensors. The person next to your car looks at you and you recognize. We talked about this. It is very interesting and important feature, and we have to use that. This is our eye, and regularly, without moving our eye up and down here, the phi degree is 2 degrees. So 2 degrees, we can see it without moving our eyes. Above 2 degrees, we have problem, and then we start moving our eyes. If we cannot move our eyes good enough, then we start rotating our head. So rotating head, rotating eye, etc. Work together. So this is related to the font size that we need to use in a certain distance. Sometimes in the courthouses, in the recent years, it is becoming traditional to make big courthouses with big aisles. Good, but the displays on doors are still small. As you walk by the corridor of the big courthouse, like in Çağlayan Adliyesi or Gebze Adliyesi, etc., big corridors, small displays on doors, in order to understand which office goes where, or also the direction signs have small letters. You need to go to the door in order to understand whether that door is the door you are looking for or not. That is wrong. The size of the display should be comparable with the distance of the reading and angle of vision, visible angle. If that is not set correctly, people have to get closer. People have to read slowly, like children's book, which slows you down. So there are certain implications. You need to watch that. And that is 2 degrees. So it should fit into 2 degree. One word must fit in 2 degrees. 1 or 1.5. At maybe 2 if the word is small. How do you say that? From 60 centimeters distance, 6-point font and 48-point font is 0.8 degrees and 0.65 degrees. So this degrees from 60 centimeters distance. And 12-point font, which is very common, right, is about 0.15 degrees. So in 2 degrees, how many letters we can fit? Can one of you can type on the right? How many letters will fit in 2 degrees in 12-point fonts? I'm waiting the answer on the chat box. Or you can say. If I ask this in class, at least certain answers will come up. Two degrees, each font, one letter takes 0.15 degrees. How many letters will fit in 2 degrees if one letter takes up 0.15 degrees? Yes, Ramazan, thank you. Ramazan says 13 or 14. There is a decimal point. So 13 letters is actually a long word or 1.5 word or 2 words. So basically one word can be read without moving your eye. Muhammad Salih, yes, it is only you. If it is too big, the angle becomes wider. When the angle becomes wider, you cannot see it at once. So you need to scan slowly. Like children's book. In the children's book, you read slowly, phrase by phrase, slow, slow, slow. So in order to read fast, it has to be small enough so that at least one word, sometimes 2 words, fits into visible angle without moving your eye. Actually, fast reading courses very heavily depend on this principle. In order to fast read something, you need to look from distance. If you look from distance with good glasses, if you look from distance, you reduce the angle of movement of your eye. Instead of moving multiple times, you reduce number of times of the movement of your eye, and then speed reading is possible. This is also some encyclopedic information. Again, you are not responsible from these numbers, but these are interesting numbers, so I am putting them here. One important thing is number of cones in each retina is 5 million. So each eye is 5 megapixel. Actually, no, because those pixels are concentrated on the center. It is much better than 5 megapixel. 100 million 5 million cones and 100 million rods. Peak cone density, this is important, 0.16 million per millimeter square. So it's the back. And how many nerves? 1.5 million nerves. Another line for the black and white as well. So a lot of optic nerve fibers going to brain, and again also number of S cones. The blue is not much, L and M is much more. So green and red is much more. And ratio of receptors to ganglion cells for the whole retina is 125 to 1. So there is a filtering and processing going on. So some processing is done in eye. So that is one important aspect. One degree of visual angle actually corresponds to 0.3 millimeters. Okay, so 1 degree in screen. So the Apple has retina screen definition. So that 1 degree goes back to 0.3 millimeters, and that 0.3 millimeters, each millimeter has 160,000 cones, each millimeter square. So 0.3 millimeter goes to 1 degree, so that you can compute how many pixels correspond to how many cones. If you exceed that number on your screen or equalize that number, your screen is called as retina screen commercially. Okay, some interesting information. 8% of men and 1% of women are colorblind. So women are more lucky here. In our class, I'm sure we have. It is not a deficiency, it is difference. So what they see is the stop sign is something like on the right. So they see color, but they see color differently, and it's mixed with the other background colors, which is usually green. This is most common. So the bird like the flower like that can be seen as the following, like brownish. Missing or inadequate type of color sensors available in the retina. So what do you read on the left and what do you read on the right? So you can type on the right. Now we are making an eye blindness, color blindness test. So, is there anybody who can not see a number on the left? Okay. What do you